We choose A, B, and C first. Pick an A. 7. Pick a B.
11.
Okay, so you can't pick 11 for B. The longest one.
So you just
The longest one is always C. So you could have switched these around. Doesn't matter. But the longest one is always C. And then you write down the Pythagorean theorem. So A squared, which is 49. 7 times 7 is 49. Plus B squared, that's just x squared, equals 11 squared, right? Because C is 11. Ugh, that's bad. I should have, 49 plus x squared equals 121. Yeah? And then I'm trying to get x squared by itself. So minus 49, minus 49. X squared equals, what is this? 11, 2, 72. And then you square root both sides. And here we are again, trying to simplify. Yeah.
Can you if I get 6 and then under the radicals 2, 6 on the outside, do you have to
That's
simplify that?
because there's no more radical anymore.
Well, I mean, would it be 3 longer?
Do you want me to continue this, or? So what times what gives you 72? 8 times what?
8 times.
8 times 9 works, but this is even. You could always just divide by 2, and you have a calculator, so you could use that. But 8 times 9 is what someone said, and so I don't need that anymore. 8 breaks down to 2 and 4. What? What?
I'm talking about the first one.
Oh. And then 2 and 2, 3 and 3. So this is what Kyle was talking about before. I don't need this because I broke it down. I don't need that, that, or that. So now I have 2 times 2, squared times 3 squared. Where the 2 comes out and the 3 comes out, so I have 6 rad 2. 2 times 3 is 6. So x equals that.
I love how I did this very, erased it off.
So-
Question?
So when you have something like that, you kind of just in a way, combine terms, after you take the.
After you take them out, yeah, you multiply them together. So whatever gets taken on the outside, you multiply. Whatever's left over on the inside, you multiply, but there's just nothing for the 2 to multiply to.
On question slide 6 through 8, if there's not an X label, can you still do the A?
Yeah, you can just
Oh, okay.
put the x in there, and then it's the same way. On this one, you're finding the missing side length, so it's the same. But tell if the side lengths form a Pythagorean triple. If you get all whole numbers, you say it's a Pythagorean triple. All are whole numbers. If one of them's like a radical, like this, then it's not a whole number. And you say, no, not a Pythagorean triple.
Yeah, can you do
Yeah, we'll do 4.